Morning, everybody.
Today is May 28th, the last day in May for geometry. There are only 8 more A days that we have left together.
Wow, we're almost done here.
We are. All right, so today, let's look at our goal or objective for learning. I can convert units from degrees to radian and radian to degrees. So let's think about what we're being asked to do. We're being asked to convert. So think about in the past when you've been asked to convert in math, you would be asked perhaps to convert inches into feet or feet into yards, things like that. So today we're going to be converting degrees to radian. If you have your graphing calculator handy right now, do you remember there's that button called mode? And when you click on mode, you have an option. Your calculator could be in radian or degree mode. It's probably our first time looking at the word radian because we've been told in the past, make sure your calculator's in degree mode.
Yep.
Right?
That was when we were doing sine, cosine, and tangent.
That's right. We had to be in degree mode for that.
Yeah, and I'm just curious, thinking about it. If you had to convert 2 feet into inches, could you tell me how many inches were in 2 feet? What helps you think about that?
Well, I know that 1 foot is 12 inches. Therefore, 2 feet is 24 inches.
Great. So that's exactly the type of process that we're going to do here is when we're trying to convert from degrees to radian or radian to degrees, we're going to have like one set unit conversion. Like I know 12 inches are in 1 foot, and no matter when I have to convert, whether to inches to feet or feet to inches, I use that same knowledge or that same statement right there. So here, to even get you started on thinking what radian is, I want you to think about how many radii, or how many, remember that's the plural word for radius, fit around this circle. And my hint to you is to think back to an inscribed hexagon construction. So that was the construction, if you remember, where we used to measure the radius. So here's a radius. You had to take your geo tool and you measured the radius, and then starting from this point over here, you would take that distance and you would make an arc mark, so it would look something like this. And then starting from this point, you did it again, and you did it right over here. And then you did it again, and it ended up over here. And then you did it again. And you did it again. And then up to here, these were the 6 points we used. But I do remember some of you used to try and do one more arc, if you remember. I mean, some of you may have, some of you may have not. Now, if you do that, if you notice, it falls a little short. Now, I tried to do it as accurate as possible, but it falls a little short. And I did that on purpose, because that is exactly how many radii fit around the circle. It's 1, 2, 3, 4, 5, 6, and a bit more. So 6 and a bit more radii fit around the circle. So I want us to focus just on half of the circle right now. If we look at half of the circle, how many radii fit half the circle?
It seems to me like 3 and a bit more.
Huh.
Ooh,
So
3 and a piece.
3 and a bit more. That kind of sounds like a special number that we know in math, Miss Murphy.
Maybe like 3.14.
Oh, yeah, it does. So if you notice, 3 and a bit more, 3.14 is actually how many radii fit in half the circle. And now that is going to help you convert from radian to degree and degree to radian because radian measure comes from how many radii fit around the circle. So let me show you something. If I were to create a central angle using this first point, this was the measure of how many radii?
1.
So this was 1 radius. So since this is 1 radius, the measure of this angle in radians is 1 radian. So now going back to this thought right here, if I had 3.14 radii for half of a circle, that's how many radians exactly? What number is 3.14? You said it before, Miss Murphy?
Pi.
So we have pi radians, and that should be equal to half a circle is how many degrees?
180.
Oh, so this right here is what we are going to use to convert from radian to degrees. This is our important unit conversion. Just like 12 inches equals 1 foot, pi radians equals 180 degrees. So what does radian even mean? What does it mean? What did we just show here?
So radian seems to me to be the measure of an angle.
And that's exactly what it is. It's just like degrees. It's just a different unit. So if I want to measure the length of something, I can measure it in inches or I can measure it in feet. So if I want to measure the openness of an angle, I could measure it in degrees or I could measure it in radians. Great. So, Ms. Murphy, do you think the number of radii that fit around the circle changes if I make the circle bigger or smaller?
No, it would not.
It would not. Just as if I think of degrees, if it's a big circle or a small circle, there's 360 degrees total. So I just want to show you a picture of 3 different sized circles. And I want you to note that the number of radians around it, so here's radius number 1 because it's a small circle. 1 radius, 2 radius, 3 radius, 4 radius, 5, 6, and a bit more. Here's a second radius. It's bigger. Since it's a bigger circle, the radius is bigger. Here's 1 radius, 2, 3, 4. Now remember, I told you can make a central angle from any one of these points. If I chose this point right here, this central angle would be 1, 2 radians. That's how you measure the angle, based off of how many radians are in the circle. And then the same thing with that third circle. So now there's something important I want to address. So we know 1 radian, 2 radian, 3 radian, and then pi radians. So we know pi radians is half the circle, right? So Miss Murphy, if half of the circle is pi, how many pi's do we need to complete the full circle?
2 pi's.
Oh, so if half of the circle is 1 pi, then to finish the other half of the circle, it would be a full 2 pi, which makes sense because 2 times pi, which is 3.14, is going to be 6.2 something. So 6 and a bit more, which is what we see here. 1, 2, 3, 4, 5, 6, and a bit more.
So 2 pi equals 360 degrees.
Exactly. But the only one we really want to use when we're converting the units is that pi is 180. Pi radians is 180 degrees because that just makes it easier for us.
You know, something else just to help me picture in my mind what a radian might equate to in degree measurement. When I'm looking at this and I'm thinking there's about 6 radii in a circle, would it be fair to say, Mrs. Talhami, that 1 radian is equal to 60 degrees approximately?
I think that's a very fair statement to say. And that's what I'm going to write down right now so you guys can understand what Miss Murphy just said. She said there's about 6 radii around the circle, which is what we just explained. There's 6 and a bit more. So if a circle is 360 degrees total, if I do the 360 degrees and divide it by 6, that means each radius is 60 degrees, about 60 degrees. So about 60 degrees per radius. And that's a very, very important thing that Miss Murphy just said. Because one radian measure, right here, is about 60 degrees. 2 radians, so this angle measure, is about 120. 3 radians is about 180. It falls a little short. So that's really a great point that you made, Miss Murphy.
Just to have a little, mental understanding of 1 radian, what that equates to. I think when we figured it out before, it really is 57.295777951. So we'll just say 60.
Yeah, because 57 is close enough to 60.
Okay.
And that point is very, very interesting because next week when we talk about finding the length of the arc, Radian measure is going to help us get that. And the fact that you know that 1 radian is about 60 degrees can help us really understand if our answer makes sense. Okay, so really there's 2 ways to convert the units, but for purposes of just being consistent, I'm just going to talk about the proportion. So in the proportion, I want to make sure I use the unit conversion that we talked about. When I say 12 inches, I think 1 foot. So what was that unit conversion we mentioned?
So pi is equal to 180 degrees.
So
1 pi is 180 degrees.
So pi radians is equal to 180 degrees. So that's important when I set up this proportion. This is what you want to write down. Every time we convert from radians to degrees or degrees to radians, you're going to write pi over 180 equals radian over degree.
Please stop and write this down. This is very important. This is the proportion you will be using to do today's lesson. Pi over 180 equals radian over degree. The more times you write that, the more it will stay in your memory. So let's try an example. Express in radian measure an angle of 75 degrees. So I would think we should start by writing our proportion. Pi over 180 equals radian over degree. Now, it seems to me in this particular question, they give us a piece of information that we can substitute. It tells us that the angle is 75 degrees. So we can replace degree with 75. They're asking us to find the radian. The radian measure. That's what we're going to find. Can we replace that with x there for Talhami?
Absolutely.
Okay, so now we have our proportion set up and we can cross multiply to solve. So 180 times x is 180x equals 75 pi. 75 times pi.
Now, some of you might be tempted to just do 75 times pi in your calculator, but if you read the question, now pi is an irrational number. It'll go on forever without repeating, so it's a very long decimal. You can't write it all. If it doesn't ask you to round, I've always said you need to leave the answer as an exact value. To leave it as an exact value, you're not supposed to put pi or multiply to pi in your calculator.
Okay, so therefore we're going to leave pi in our answer. So to get x by itself, we're going to divide both sides by 180. And therefore, we have 75 pi over 180. But when I look at 75 pi, 75 over 180, I think that we can reduce that. And I know that answers should be reduced whenever possible.
Absolutely.
So we can do alpha y equals 75 over 180 equals, and you'll see that your calculator reduces it for you if you have difficulty, to 5 over 12. We're going to keep that pi in the numerator, 5 pi over 12.
And that's how
And
many
label it.
radians?
Yes.
So
That's the unit measure, radians.
So 75 degrees equals 5 pi over 12 radians. Now, if it does ask you to round, I could do 5 times pi divided by 12, and I get about 1.3 radians. Which, if you want to picture what that looks like, if I know this is about, so I'm going to do it a quick side note. If this is about 1.3 radians, you can picture yourself a circle and say, well, if this is the radius, here's 1, here's then going to be 0.3, something like that. So that means my angle, my central angle, would be this. So I know it's a little bit more than, or about, a little more than 60 degrees, because we said 1 radian is about 60. Hey, look.
Yeah, when I look at that, Mrs. Talhami, I think of a 90-degree angle to help me figure out that it's less than 90 degrees.
Absolutely. And it has to
be that
be
much less.
But it has to be more than 60 because 1 radian is about 60. Look at the number we started with. If it's more than 60 but less than 90, did we kind of do this accurately?
We did.
Yeah.
So you can really judge the reasonableness of your answer.
Absolutely. All right.
Okay.
Let's do this next one. First step.
Oh, boy. This time they throw in a little fraction for us, but that's not going to change our method of using our proportion, pi over 180 equals radian over degree. So let's read the question. It says, find the degree. So that's our x. We're finding the degree. Degree is x. Measure of an angle of pi over 4 radians. So we can replace radian with pi over 4.
And you can have a fraction within a fraction. So just make sure the degree is x and the radian is pi over 4. Because some people put pi over 4 and then they don't get the right answer because they didn't put it in the right spot.
Okay, so we can still cross multiply. So we have 180 times pi over 4 equals pi times x. Remember, we're trying to get x by itself because that will give us the degree measure. So to get x by itself, I would divide both sides by pi. All right.
Then look what happens.
Now let's really take a look at that side.
If I have a pi on top and a pi on bottom, it's gone. They reduce. So I'm left with 180 and 1/4.
So that's 45. A fourth of 180 is 45. I actually just multiplied it in my calculator, Mrs. Talhami, by 0.25. I know that 1/4 is 0.25.
Yeah, you could do that as well. And there you have it. That's how you convert from degree to radian and radian to degree. So here are some 10 practice problems. If you want to pause the video here, come back, we can have the answers for you.
Every time, don't forget to write your proportion, cross multiply, and solve. And you can leave your answers in terms of pi. That means pi is allowed to be left in your answer. Okay, see you in a few. Go.
Okay, so hopefully you've completed the practice problems. I'm going to zoom in so you could check your work and pause where you need it. Notice how every time we complete this, we're writing our pi over 180 equals radian over degree, and we're just substituting what we know, and then we're simplifying to our final answer here. You know, while we were doing these problems, Miss Murphy had a great question for me. Miss Murphy, would you like to ask that same question?
Well, you know, when I'm learning something new, Mr. Talhami, I always want to understand why anybody would want to do this. Why would we want to know how to measure something in radian when we already have degrees? Why isn't degrees good enough? And I went back to something that you said earlier in the lesson where you told me that radians helps us to find the length of an arc. So, you know, I'm thinking to myself, an arc is a piece of a circle. How would I use a wooden ruler to measure an arc since it's curved? And I said to myself, I wouldn't be able to do that. I would need a rubber ruler to measure the length of an arc.
Exactly.
And if you really expand that to something much broader, how do you think scientists measure distances around planets, which are circular? They don't have a ruler. They don't have a rubber ruler. I mean, you have to have something that you can do on paper, right? We're not going to fly around the moon measuring something. So radian helps construction workers, right? If you're an architect,
absolutely,
or you're a scientist, measure curved pieces so that if we were to straighten them out, we could see how long they were. And so that's really the purpose of this lesson.
Absolutely. And you'll see that more next week as we get to the length of these arcs. But, you know, at this point, if you have any questions, make sure to reach out or to myself or Miss Murphy. And I hope you guys have a great day. Hang in there. We're almost done.
Do your castle learning when you're done with this lesson. And don't forget to log into both Concepts, has a spiral review, and your regular geometry lesson. Have a great day. Bye, everyone.
Bye.